Alright guys, welcome to today's class. So what we're doing in today's class is a topic called particulate nature of matter, chemical formula and equations, then law of chemical reaction. And these are second free class on chemistry. So let's dive into it. So the first question we're going to be doing here is the empirical formula of an oxide of nitrogen containing 30% of nitrogen is. Now whenever they say something is an oxide is a compound that contains oxygen and other elements like that. So if I have nitrogen oxide, so it means I have nitrogen and oxygen. Now in this question, they did not say nitrogen 4 oxide, they did not say nitrogen 2 oxide, they did not say nitrogen 1 oxide. So it means whether it is nitrogen 1 oxide or nitrogen 2 oxide, we don't know. But they just say that the percentage of nitrogen in this substance is what? 30%. So what they are trying to say automatically is that since nitrogen has already taken 30% of this substance, it means the rest will be 70%. And you know that oxide of nitrogen means it's only nitrogen and oxygen, right? So it means the remaining 70% will belong to oxygen. If you get what I'm trying to say, what I'm saying is nitrogen already covers 30%. They already said it in the question that nitrogen, they said the empirical formula of an oxide of nitrogen. What do you mean by oxide of nitrogen? Oxygen plus nitrogen. That's what they are saying. So that's the compound. You get what I'm saying? Now they now say 30%. Nitrogen is taking 30%. And you know that we have total of 100%, right? So it means the remaining 100% will be what? 70%, and that one will belong to oxygen. So that's what they are trying to say. So they now ask us to find an empirical formula of that oxide of nitrogen. Now, before we can do something like this, we need to know the molar mass. So the molar mass of nitrogen is 14, the molar mass of oxygen is 16. So the next thing we are going to do after doing the percentage, this is the method for getting the empirical formula of an oxide. So this is the method. So if you don't know how to do it, this is how to do it. If you don't know how to do empirical formula, this is how to do it. So percentage composition, right? Now the next thing is the molar mass. The molar mass is nitrogen is 14, oxygen is 16. So the molar mass, what's the molar mass? 14. That of oxygen is 16. Now the next thing you want to do is you want to divide 30% by 14, 70% by 16. So let's bring out our calculator. And although this is a JAMB class, we should not be using calculator, but because I don't have the luxury of time to be checking the calculator for my phone. So 30 over 14. So mind you, don't rely on this because you are not going to be allowed to use calculator. So 2.121428. Let's quickly write that down. So 2.1428. So I think I have to, because of our time, let me quickly use my phone so that it can be very fast. Although you are not allowed to use calculator, but UTM will not give you something so complex. And even you will be given calculator in UTM, that is the calculator that is inbuilt. So although you will not be able to do much thing, but you still have to know how to be perfect with it. So let's quickly do that. So that divided by 14, that is 2.1428. So just say let's say 29. So I prefer 4 decimal place. So anything you like, just use it. 17 divided by 16. So that's 4.375. So I just put 0. So divide both sides by the smallest. Now the next thing you are doing is what? Divide by the smallest. So which one is the smallest? So the smallest is what? Is 2.1429. So you divide by it. So approximately we are having something like 1. Here you are having something like 2. So you can see that you don't even need a calculator in some of them. So now the next thing you are going to do is, now what do you have under nitrogen? We have 1, right? So we now bring that 1 beneath as a subscript. That of oxygen, we will bring this to be the subscript. So what's our final answer like that? Our final answer is NO2. So you can see that this thing is not hard. Our answer is option C. So this is how to find empirical formula. So if they ask you to find the molecular formula, they will give you the relative molecular mass. Maybe they say it is 60 or something like that. So what you do is you do this like this. You say 60, right? Then you input your molar mass. So it will now be 14 plus 16 times 2. I think you get what I'm saying now. X is equal to 60. I'm just using this as an example. So 14 plus 32 now into X is equal to 60. So 14 plus 32, that's around 46. X is equal to 60. So you just divide both sides by 46. By 46. So whatever you get. So don't let me use 60. Let me use something like 92. So 46 divided by this, so we have 2. So our X is 2, right? So we now bring it there. So we now become N2O4. Do you get now? So that's how to find a molecular formula. So some of the times the molecular formula can be, instead of having 2, you may have 1. So you get, some of the times your empirical formula equals to your molecular formula. So just know that. So this is just, now the second question, they said how many grams of hydrogen bromide would exactly be required to react with 2 grams of propine? Now this type of question, what is, you need to firstly ask yourself, what do we mean by propine? You need to know the formula for propine. Propine is actually an alkyne. This is in my organic chemistry video. So if you want to buy the course, it's actually a special self-paced course. It's 3,000 naira if you want to get it. So I talked about everything you have to know about organic chemistry. So it's 3,000 naira. So if you want to have the course, you can let me know. And message me on my DM on my phone number 091 5146 3635. So you can message me on WhatsApp to get the self-paced course. It's just 3,000 naira. So you can get it, everything you have to know, and there is also more for it, more place for it. So okay, away from that, so propine. Now propine, you hear the word prop. Prop means the carbon is 3, right? Now what's the formula for alkyne? Alkyne is H2N minus 2, right? So propine means you have C3, right? So it means your N is equals to 3. So it should now be C3 H2 into bracket 3 minus 2. So then you have C3 H into 2 times 3 is 6. 6 minus 2. So that is, sorry, 6 minus 2, that is 4. So this is what propine. So we ask what is propine. So this is propine. Now, what they are now asking us is how many grams of HBr will exactly be required to react with 2 grams of propine. Now this question is actually tricky because you just wondering that what are they trying to tell us? Now what they are trying to tell us in this reaction is that how many HBr will you use? You know that this alkyne, they exhibit the reaction called addition reaction, right? So they are triple bonds. So for you to combine them for you to convert them to alkene, you need 2 molecules of hydrogen. You need 1 molecule of hydrogen, right? For you to convert them from alkene, for you to convert alkene to alkene, you need another 1 molecule of hydrogen. Now here, if you look at this one now, it's just like as if you have hydrogen, right? So it means for you to convert what they ask us to do is this question. They want us to convert this triple bond into single bond. Now, and this is in what? Triple bond. And if you have this HBr once, it means you just convert it to only double bond. But the question is asking us to convert it to what? 1 single. You can just tell me that, sir, but they did not say about single bond. They did not talk about anything like single bond here. You just wonder that what is this man saying? You don't even, because you don't know organic chemistry very well. So, but in that course I talked to you about, want to know about, just message me and let me put it through. So this is propine. The question is how many HBr do you need to convert this propine to a saturated hydrocarbon? That is, you want to make it single bond. So it means you need 2. You need 2. So let's add everything together. So it will now be C3. How many H do we have like that? So we have 2 hydrogen here. 2 hydrogen plus 4 hydrogen. What do we have? 6. So then you have 2 bromine here, it will not be Br2. So that's how to get it. Now look at this. 1 mole of propine. 1 mole of propine. It requires what? It requires 2 mole of hydrogen bromide. No be so, na so. So now the next thing you want to do is you want to know the grams. You already know the number of moles already, that it is 2 moles, but the question is asking us grams, not moles. So it means we are looking for mass. That's what the question is asking us to find. Now this now said 1 mole of propine is now let's look at the mass of propine. You know propine is C3H4, right? Now what's the molar mass of propine? That C is 12, H is what? 1. So let's do that now. So C is now be what? 12 times 3 plus 1 times 4. So what do we have? 36 plus 4. So what do we have? 40. So that's our answer. So that's the molar mass of propane. So now we have 40 grams. So that's the molar mass of propane. Now what's the molar mass of hydrogen bromide? Now the problem here is they did not give us the molar mass of bromine. So let me check the question to ascertain the molar mass of bromine. It did not give us. Okay, the molar mass of bromine is 80. So that is the molar mass of bromine. So 80. So HBr will now be what? HBr will be 81. 81 gram. Now 1 mole of propane. Now 1 mole of, you know there is one formula in chemistry that says number of moles is equals to mass over molar mass. No be so. Now so 1 mole means, number of mole means that's 1 mole. They said is I already told you that 1 mole of propane so that one will be 1 mole, right? That's so mass over what is molar mass? Molar mass of propane. That's 40, right? So let's bring it. So what is the mass like that? So the mass is 40 grams. So 1 mole of propane is what? 40 grams. Equivalent to 2 mole of HBr. So it means you will multiply. Okay, let's do that now. So it will not be 2 mole. In place of this now, it will not be 2. So 2 will now be equals to mass. What is the molar mass? We said 81. 81 times 2. So that is let me quickly paste my calculator. 81 times 2. So that's 162. So that would be 162 grams. Now we are not doing this. They now said 2 grams of propane will now give us what? So it will now be 2 grams of propane will give us what? So we are looking for what it will give us. So let's assume this is our x. So let's cross multiply. As if we are doing cross multiply, it will now be 40x is equals to 162 times 2. So you don't even need the calculator here. So 40, 2 here, 20. So 2 here, 81. So 10 in 81, that will be 81 grams, 80.1 grams. So that's our final answer. I think you get the way I did it. So just the method, that's the method I used to get the answer. I hope you understand the way I did it. So please, if you want to know about this organic chemistry very well, you can pay for the self-paced class, and even if you are in our paid class, you can just be rest assured we're going to teach it in the paid class, and you don't need to pay for another money again. So the paid class is actually very, very important. So the third question here we're going to do is the empirical formula. I already told you how to do it already. So they said the carbon is what? 72%. The hydrogen is what? 12%. And the oxygen is what? 16%. So that's your percentage composition. The next thing you're going to write is what? Is your molar mass. So that will be 12. Look at it. Hydrogen is 1. Oxygen is so 12. When hydrogen is, oxygen is what? 16, right? So just divide everything. So 72 divided by 72 divided by 12. So that's 6. So 12, 1. So this one is very, very simple. So at the end of the day, what are we going to have? So you don't need to divide by the smallest. So you can see that every time you follow a particular singular template, it will be everything. So you can see now. So that's the answer. So our answer will now be 6 is H12. So that's our final answer. So that was how to do it. So please make sure you solve more questions like this so that you can know more. So the next question states thus: if 1 mole of aluminium contains 6 times 10 raised to the power 29 atoms of aluminium, how many atoms are contained in 0.9 gram of aluminium? And they say the molar mass of aluminium is 27. Now, how do you do something like this? This is how to do it. So the solution, I'm not sure I'm using the solution how this way. I'm just solving question. Okay, don't worry. So they gave us that 1 mole of aluminium, it gives us contains 6 times 10 raised to the power 23 if atoms. Now, with this that they gave us, they've already given us a clue. Don't forget what I told you in one of the questions we did. That number of mole is what? Mass over molar mass. Now, if you look at this question, they've already given us 1 mass, but this mass, just leave it. Do you get? I will tell you where to use it. Now, let's look for mass. Now, they give us 1 mole here, right? So let's say 1 mole is equals to mass over, what's the molar mass they give us here? 27. So let's use that 27. So our mass will now be equals to what? 27. So you know you multiply 27 times 1. So that would be 27 gram, right? So in place of this 1 mole, what are you going to write? You're going to write 27 gram of aluminium. I think you get what I'm doing. So it should now be 6 times 10 raised to the power 23 atoms. I hope you understand. Now the next thing we want to do is, they now gave us the 0.9 gram. They now said how many atoms? So this one is atoms. They now gave us gram. So it means when we write this gram, we'll be under this gram also. So it will now be 0.9 gram of aluminium. We now give us how many? They've already give us. They've already said this is what we are looking for. So it will now be how many atoms? That will be X. So let's multiply. So that will be 27x is equals to 6 times 0.9 times 10 raised to the power 23. Sorry. So let's do it like that. So what do you think will be your answer? So just divide both sides by 27. So then you finish your work. If you look at this calculation, they are not easy to do without calculator. The reason is because those questions are the question they said when calculator was allowed. So don't be confused. So they are divided by 27, so it will be 0.2. So 0.2 times 10 to the power 23. So what do we have like? So final answer will be 2 times 10 to the power 22 atoms. I think you know how to express in standard form already. So that's what I did here. So don't be confused though. I just used standard form. You know, normally it should be 2 times 10 to the power minus 1. You want to convert it. So this 0.2 is 2 times 10 to the power minus 1 times 10 to the power 23, which will now be 10 to the power minus 1 plus 23. So that's your standard form. It will now be 10 to the power 22. So that's how I get this. So don't be confused that I just jumped from step. So what's our answer like that? So our answer is option C. So if you don't get anything, just make sure that you go through the video over and over and over again, because those questions is actually very, 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 very important. It's very, very, very important. So don't be confused. So the answer is what? C. So let's go to the next question. So the next question is, the formula of a compound formed in a reaction between a trivalent metal M and a tetravalent non-metal X is. Now,
when they say something is metal, a metal is a cation. So what are cations? They are positively charged elements.
So they are the ones that we carry plus on the top like this. We have a plus like this. Those are the cations. But when we are talking of anions, they are
non-metals, so they are anions. So when you have something like this, you have something like minus now.
So these are anions. So example of cation is sodium, potassium, calcium, aluminum. So those are cations. Anions are something like oxygen, chlorine, what else again? I think phosphorus is 3 minus. I can still remember. Yes, phosphorus is 3 minus. So please, and so on and so forth, try to know them, sulfur too. But that's not what I want to do now. So let me try to rub it. Sorry. Oh God, I cannot clean this thing because it's a PDF I use as. That's the disadvantage. Oh God. Let me make sure if I can use other method to clean. Oh God.
Okay, let's quickly do it now. Okay, alright. So sorry for the outage. The system was actually hanging, so that's what caused the delay. So the formula of the compound formed in the reaction, I told you that I've established the fact that trivalent metal. So metal now, they don't say trivalent. When something is trivalent, it means it will carry 3 plus.
If they say divalent, it means it will carry 2 plus. If they say monovalent, it will carry plus. Do you get? If they say tetravalent, although I don't see something like 4 plus before. Do you get? So now they now said M3 plus. So they now say trivalent. So it will be trivalent metal. So it will be M3 plus. They now said if it combines, so it will be and a tetravalent non-metal. So this non-metal X will be 4 minus like that. Now this is how to combine elements. This is how to combine. It's just like you do cross multiply. 4 will come here, 3 will come here. So it will now be M4S3. So that's our answer to what? M4S3. So that's option C. That's the answer. So the next question is this. Now this question is actually very tricky and it's going to please, I want you to please give me your attention. So how do you do questions like this? This is how to do it. Now they said, what are the values of x, y, and z? So this is just like balancing an equation, right? This is how to do it. So what I have to do is, now the first thing we are going to do is, let's look for how to get y. Because this y, we can easily get it. Because y, it advertises the value of hydrogen. So why now equals to, look at this hydrogen now. Hydrogen is only found in only one product, right? So it's easier for us to know the value of Y through this hydrogen. So it means if you look at this hydrogen now, it is 1. It is, hydrogen is 1 here, right? When you equate it to the hydrogen here, so it will be 4 times 2. Do you know what I'm doing? Normally, if you want to know the number of hydrogen here, it will be 4 times 2, right? So our Y is equal to 4 times 2, so that is 8. We have already get to the first thing. Now, the second thing we want to get is, let's get X. Using what? Okay, let's get the value of Z. Let's get the value of Z. I think I omitted something that I need to get. Okay, I don't omit anything, but let's look for the value of. So this one is for hydrogen. This is for hydrogen. The next one I want to do is for nitrogen. Now, how do we do that of nitrogen? If you look at nitrogen also owns this Y. So we are now going to say Y is equals to, look at nitrogen here. Nitrogen is also here too, right? If you look at nitrogen here, nitrogen owns this Y. It also owns this 2. So it will be 2x. I think you get what I'm doing. Do you get 2x? 2 times nitrogen plus times x also, so it will be 2x. You don't need to put nitrogen here again because we are talking of nitrogen. So 2x plus nitrogen is here also, so that is Z. To write nitrogen into, so that's for nitrogen. Now we already know what Y is, so it is 8. So that is 2x plus Y. So that's our equation 1. Now the next thing we want to do is we want to do that for oxygen. So for oxygen will not be, oxygen also owns this Y too. So it will be 3Y. Oh, sorry. Okay, sorry. Yes, I think I made a mistake in one of the thing I was doing. I made a mistake. So what I'm doing now is I'm doing that of, let me do that of oxygen now. For oxygen, it will be 3Y. Do you get? It will be 3Y is equals to, look at oxygen here, 2 times 3, 6 times X, that is 6X. Now we still have another oxygen here. So that's a double wala for them body. Now how many oxygen do we have here now? So that's 4 times 1, so that is plus 4. Do you get? Now oxygen is here also, so plus Z. Don't forget, we already know what Y is. That is 3 times. What is Y? 4 is equals to 6x plus 4 plus Z. So that would be 12. Or what do you think? That would be 6x plus Z plus 4. Do you get what I'm doing there? So what are we going to do now? We're going to bring this 6x plus Z. We now bring it to this side, so it will now be 8. So 12 minus 12, that will be 8. So let's bring this one to 2x plus Z is equals to 8. I think you get what I'm doing, so that's what I'm doing currently. So the next thing we want to do is, let's divide both sides by, if you look at this, sorry, this is a Z, there's no way we can divide both sides. So let's, this is our equation 2 like that. This is our equation 1. So let's remove them from each other. So it will be 4x is equals to 1. And we are getting something like 1 over 4. So there's something wrong. I made a mistake in one of the places that I'm doing. I made a mistake. So I think I made a mistake maybe in the value of Y. Sorry. The value Y is actually 8 and I use 4 for Y. So sorry for that error. Y is 8. Why is 8? So sorry. I can see you can make mistakes some of the times. Oh god. And this free class is even getting much far than the way it should be. So okay. Now good. Okay, alright. The system was hanging again. So 12 minus 8. Okay. So where did I say I made a mistake? Sorry. Okay. Let me prepare a bit. So now I made a mistake here. So instead of 8, it should be 8 here. So that will be 24 is equals to 6x. So it's this place it should still be 4. I don't know why I keep making mistake like that. So first 4 plus z. So bring 4 to this place. So we have 20 is equals to 6x plus z. So let's bring everything together. So don't forget we have 2x plus z here. Let's use this equation so that we can quickly get our answer. So that's our 8. So what's our x now? 3. So what's our, we have what? 6 plus, sorry. This is z. So that is 6 plus z is equals to 8. So what's our z now? Our z is 8 minus 6. So that is 2. That's our final answer. So you can see now. So this is how to do the end question. So they now ask us to find x, y, and z. So our x is 3, our y is 8, our z is 2. 3, 8, 2. So that's our answer. So you can see this question is somehow tricky, but if you are able to, but the thing is actually that if you are a person that you do chemistry very well, you should know that this equation, this is a equation for when you react concentrated triazonitrate 5 acid, when you react with copper. So this is the reaction you're going to get. So this is for dilute. This is for dilute. That's the concentrated is different. That's the dilute is different. So please, all these things, you know them, you don't need to go through all those stress. You know them often. Because our Mr. Evans has taught us all these things before. We just do it. I think we are going to do this. We are going to do this. We already it's already part of the things we are going to do in the class. The descriptive chemistry. So all those things you don't have to worry about them because we are going to do them. So NO2. So this one is for concentrated. Sorry. So this is for concentrated. This is for dilute. So once you know it before, you don't need to worry yourself again about this because I want you guys to know how to solve it on your own, even if at all, if you have not come